Vectors are mathematical entities used to represent both magnitude and direction. They are commonly used in various fields including physics, engineering, computer science, and mathematics. Some examples of vectors as used in physics are: vector arrows are used to represent vectors. You can use a scale to accurately represent the magnitude. The direction of the arrow signifies the direction of the vector. Vectors can be represented using coordinates or components, which are typically numerical values. A vector is usually denoted by an arrow above a letter, such as. It can be represented as an ordered collection of values in different dimensions. For example, in a two-dimensional space, vector A can be represented as. We can graph the vectors. The starting point will be at the origin, the coordinate is 0 and 0. We name it point A. We choose point B, with coordinates 4 and 0. Draw the vector arrow from point A to point B, we name it as vector U. We choose another point and name it point C, with coordinates 0 and 5. Draw the vector arrow from point A to point C, name it vector V. These vectors are perpendicular to each other. The angle between vectors U and V is 90 degrees. Vectors interact with one another. As an example, consider the flow of the river and its effect on a boat trying to cross the river bank. The resultant movement of the boat will be deflected. This is also theoretically equal to the resultant vector, which is at point D, the intersection of point A and B, the coordinate of point D, is 4 and 5. Connecting point A and D gives us the resultant vector, W. This can be solved using the Pythagorean theorem, and the angle can be solved using trigonometric functions. We can also use matrix to represent a vector. Let vectors A and B be represented by giving them numerical data yields. We can use this technique to carry out scalar multiplication. Consider vector A. As it is multiplied to a scalar number 3. Let's use numbers to show that. Scalar multiplication changes the magnitude of the vector and orientation of the arrowhead, but not the absolute value of the angle. Using the matrix to represent vectors then carrying out vector operation is also possible. We have vector A and B. We add them. We use numbers and find out that the length of the resultant vector is found using. We go to the dot product. It tells us about the angle between two interacting vectors and is closely related to the cosine law. The dot products of vector A and B is given by substituting numbers in place of letters yields. We can interpret the results of the dot product operations in the following manner. The dot product can tell us about the angle between the interacting vectors. If the angle is acute, the dot product will be positive. If the angle is obtuse, the dot product will be negative. If the angle is exactly 90 degrees, then the vectors are perpendicular to one another, the dot product will be 0. We now apply the dot product and see how it is related to the cosine law. Consider the vectors u and v as shown in the figure. We compute the magnitude of u and v. We get the formula for the dot product of two vectors from the matrix version. We plug in the values. We try to apply the cosine law to the right triangle. Using the matrix and the vectors, we rewrite the cosine law as, which can be simplified using the dot product. We will see that applying the dot product to get the angle between vector u and v, we have the dot product of u and v is 0. The length of u and v is 4 and 5, respectively. We see that 0/20 is equal to cosine theta. Theta is equal to arc cos 0/20 is equal to 90 degrees. Thank you for watching. We hope that we have helped you in understanding the topic. Subscribe for more videos. See you again here in the YT University.